Swayam Prabha. Digital India. Educated India.
Right? So there are a whole bunch of different terms that get thrown around. I don't know. We can't really get into the full details of it. I'm going to give you a very high level intro to all of these. Right? How many of you heard Gen AI? Okay. How many of you heard term foundation models? Just one of you, 2, 3, 4. Okay. You don't know foundation models. Okay, great. So what about large language models? LLMs? Okay, great. Fine. So Gen AI is all about, people who are talking about generating all these images and stuff like that, but it's a lot more than just generating images. So we'll step back and ask what Gen AI is, right? So normal AI, right, which is this whole machine learning or supervised machine learning we're talking about, learns from this kinds of data to answer questions like this. Okay, I give you a picture, I ask you what is the label, right? And I want you to say it's a dog. Okay. But Gen AI, so I'll give you the similar kind of data, but instead of giving you a picture and asking you what is it, right, I'll give you a tag. I'll ask you to generate a picture that looks like the tag. Right? So Gen AI is generative of the inputs that were given to you for training. Right? Normal supervised learning is learning to predict the output that was given to you during training. Like Gen AI models learn to predict the input that was given to you for training, right? So there you go. That's a picture of a dog. Right? So notice that this dog that is generated is not here in this row. I mean, you can't see it from too far back, but this is not the dog in this row. So what I'm really looking for from Gen AI systems is not a retrieval mechanism. Right? When I ask you for a dog, I don't want you to go back and give me a picture of a dog from your training data. I want you to generate something that looks like a dog, right? So it could potentially be something that you have never seen before as well. Right? Kind of, some function again, just like you had in the forward problem, right? When you were doing the supervised learning, I said you had to make some assumption about what will be the nature of the function. Likewise, you have to make a similar assumption about what will be the nature of dogs before you can generate a dog. Yeah.
So do the AI that tend to steal art?
Yeah.
So do the AI that tend to steal artists?
Still doesn't work, but anyway. Yeah. Okay. On, you're not talking very loud.
So do the AI that steal the artist's images work on this generative AI processing or?
Some of it uses generative AI. Some of it actually uses kind of a pixel coloration technique. So basically, it learns, okay, given this pixel, what should be the color of the pixel? So it actually treats it as a labeling problem, just like we had for the object recognition, right? So I'll give you a picture. I want to say it's an airplane or not, right? Now I'll give you a pixel in the image. I want you to tell me whether it is red or pink or blue or what, right? So some of those coloration things uses generative AI, and some I don't quite remember in those pictures which one used what, but most of it was using supervised learning only, not the visual discriminative learning. Okay, good. But then generative AI is not new, right? It's not that OpenAI discovered generative AI. It's been around for 2 decades at least. Yes, ma'am.
Sir, I have a doubt.
Yeah. I presume that's why you put your hand up. Yeah.
Sir, you had mentioned that.
You have the advantage of location, but I think you have to speak up for the camera. Yeah.
Sir, you had mentioned that there are certain assumptions that are to be made
Yep.
for the AI to generate a picture of the dog.
Generalize, yeah.
Yeah. So are these assumptions fed into the computer by the user, or does the machine itself learn?
No. So when you set up your deep learning system, right, or when you set up your machine learning system, So you set up the constraints automatically. That is what it is. So the constraints are in some sense fed in by the user. Yeah. So it doesn't run the constraints. Okay. So what do I have here? So there is this one technique that people use for training the generative model, which has been around for some time now, right? So I mean, generative, like the generative AI that goes back 2 decades, right? It's very, very simple. Okay. So I'm not getting into that. I'm just talking about some of the more fancy ones now. So this came out in 2017 or so, 16 or 17, called generative adversarial neural networks. Okay. So the idea here is very interesting. That's why I put this up. So you have your data, right? So these are all real images. Then you have your generator, right? Let's not worry about how the generator itself functions, but the generator will produce some image, right? There are different ways in which you can build the generator. The generator will produce an image. Now what you do is you take a real image and compare it with, so both of these are fed into the discriminator. Now the discriminator is like the classifier that we talked about earlier. The discriminator can say whether this is a real image or whether it's a fake image. It can say it real or fake. That's what it discriminates, right? So if the generator is so good that the discriminator is not able to tell apart whether it's a real image or a fake image, right? Reminds you of the Turing test, except that instead of a human being, you have another machine here, right? So if the discriminator cannot tell apart whether it is real or fake, then the generator is good, right? So if it is able to tell that apart, that goes back as a signal to the generator saying, hey, look, you are not fooling the machine yet, so you have to change your outputs. So that's basically how it functions. So depending on the mix of images that you give, right, mix of real world images you give here, right, the discriminator gets fine tuned for certain kinds of outputs, right. So then the generator becomes very good at producing those kinds of outputs, and it won't generate random stuff, right. Okay. So why it won't generate random stuff? So even if it generates a random but very realistic looking image of something which is not there in the real data set, the discriminator can tell you very easily it is fake, because there were no tigers in the data set. So you produce a very valid image of a tiger, I'll still know it is a fake because the tiger was not there in the data set. So what the generator will learn is to generate very realistic images matching what is given in the data set. Okay, that's a very simple, yeah.
Sir, in this flow chart, there's that thing called noise, right, from which the generator is generating image. So what is that?
Noise is noise.
Just noise.
Yeah.
And so from the sound, it is generating an image.
Noise meaning, so in the olden days when or even now, right, if you don't have your TV signal coming in, you turn on TV, right, you'll see a lot of black and white speckles on the scene.
Yeah.
That's noise.
Okay, so that's called noise.
Yeah. So noise is, any signal that doesn't have. You had your hand up. Yeah.
So the generator learns using the discriminator by discriminating between the real and the AI generated like images.
Yeah, the discriminator learns also to discriminate between real images and AI generated images.
No, in the initial stages, the generator will not be that good. So how will the discriminator like discriminate properly?
Discriminator will be great, right? See, you know which image is being fed into the discriminator. See, remember, how are you training the discriminator? Just like you trained the original system, right? So I have a bunch of images which I say are airplanes. I'll have a bunch of images which I say are cat, whatever, right? Now I train it, okay, if this is the input, you have to say it is an airplane. If this is the input, you have to say it is a cat. That's the information I'm giving it, I'm training it, right? So for training the discriminator, I'll say, okay, for the initial parts, hey, this is a real image and this is a fake image, right? I'll train the discriminator. And after that, when a new image comes out, it has to say whether it is a real image or a fake image.
Now, how do we know which is a fake image when the generator is not that much good at that initial stage?
I know, right? And as a system developer, I know whether the image is coming from the data set or the image is coming from here. So at every point, the human who has set up the system will know whether it is a fake image or whether it is a real image, right? It's not that I'm looking at the picture and telling you whether it's real or fake. From the program, I know whether it came from this path or this. So I'll know whether it's real or fake all the time, right? Afterwards, only when I spring the generator on unsuspecting public, they get fooled by the images. But as a designer, I would know at every point of time whether the image came from. So, yeah. Going on, okay, I'll skip on this, but this is a way, this is a very, very weird way of doing this, but this is one of the most popular way of generating images now. So, you start with a real actual image, right? You start with an actual image, keep adding noise, right? Add a little bit of noise, little bit of noise, little bit of noise until it becomes fully noise. You remember the trajectory you did to get there, right? You remember the trajectory. So from here, this is what happened to the image, that's what happened to the image, and so on. Now what you do is you go back, keep removing noise until you get back to the original image, right? So keep doing this for many sets of pairs of images, but at the same time, you are basically learning what is the process by which I removed noise to get to the image. Right? So you can't do it in one shot. From here, if you go here, you learn nothing. Right? So you have to go this in a step-by-step manner so that you know what is the direction you are pushing the image to get to noise, and then you learn how to push the noise out and get back to the original image. So these are called diffusion models. So it's a very nice process, right? It's mathematically very well characterized and described and all that. And so basically, what happens is once I have learned how to do this, then I'll give noise, just noise as the input, some random noise as the input, and ask it to start denoising it to come back to a original, some image, right? So that's basically what is happening with these kinds of diffusion models. So you can use a diffusion model in your GAN and get it to train it to do better. Right? So bunch of things are possible. So very quickly, we have a lot of time. So talk about foundation models, right? So we do something similar to what the generative AI did, right? But try to do this with really no data, no labels, right? Try to do this without labels, just by looking at all kinds of inputs, right? So it's sometimes called unsupervised learning because you don't have any supervision, you don't have any labels, let's say cat, dog, or whatever, right? But sometimes it's also called self-supervised learning because what you are really interested in is producing the same input as the output, right? So you are having an output. So earlier the output used to be things like cat, dog, and things like that, labels, right? Airplane and so on and so forth. But now the output you want to produce is the same thing as the input. Hey, if I give you as the input, do something to it and then come back to me with the same input, like we're talking about, adding noise and removing noise to get to the same input and things like that, right? So it's sometimes called self-supervised learning. And so what is it? The foundation models is, instead of a small data set that we are talking about, they are trained on very large volumes of data. In fact, most of these large models that you see out there, the GPT or Gemini or whatever, are literally trained on a large fraction of the internet. Right? They just go out on the web and get all kinds of data they can get their hands on, right? And then train the model. So that's something that distinguishes foundation models from other kinds of models. And they learn billions of parameters, right? So, but the idea is that somehow at the end of this learning process, you have learned to produce any signal that could potentially exist in your input space, right? If it is text, I can produce any kind of text. If it is image, I can produce any kind of image. If it's some voice, I can produce voices from that, right? So that's basically the idea here behind foundation models, right? So what are large language models, right? They're literally foundation models for text, right? They're trained on huge volumes of data and they can generate text, right? But the premise behind language models itself is something very simple, okay? So I will run you through some exercise here. Okay, here is a simple exercise. So I give you a fill in the blank. Fill it. Movie. Anyone else? Any answer other than movie? The mic is.
Monkey jumping.
Monkey jumping. I watched a monkey jumping. Huh? You can see a monkey jumping. You watched a monkey jumping. You stood there and watched it. No, fine. I mean, you can. I'm just surprised that you stood there and watched. Anyway, fine. Then Man, TV show.
I watched a car.
Car. Nobody watches IPL. Huh? I was expecting somebody to say I watched a match. I mean, anyway, there's no right answer or wrong answer here, right? There are many, many possible ways in which you can. You said match. You didn't use the mic. I didn't hear it, basically. That's fine. Okay. We still have it here. So, fine. So, things like, right, there are no right answers, but all of you gave me different answers, right? On what did you base your answers on? Or things that you do more often than not, right? Oh man, the classroom became inhospitable immediately. Can we get the fan back on? Thanks. Okay. Fine. Let's say let's change that. Fill in the blank. Movie. Oh, yeah, you said movie. You're not going to change it. But now more people are more confident in saying movie, right? So match and game and all that you don't watch in a theater, right? But movie, maybe play and so on and so forth. So this piece of text I gave you is what people are nowadays calling prompts, right? In this LLM thing, you give ChatGPT a prompt and then it gives you a completion, right? And as you can see, the more context I give in my prompt, the more sure you become about your completion, right? So what is happening here is that we subconsciously order things by frequency, right? In fact, you probably did not reason that, oh, theater, there will be no matches, it has to be a movie or something. You basically just did that by frequency. Hey, in the theater I watched, of course, a movie, right? I mean, you're not even reasoning about these things. More often than not, right, we don't use things like grammar, right? So when you speak a sentence, right, you're not making reference to your Wren and Martin, right? You just speak it. I don't know, do you guys use Wren and Martin anyway nowadays? Anytime in school? No? Grammar book? Oh man. What do you learn grammar from? English grammar. What is this thing called English grammar?
Just the norm what we are supposed to do.
Sorry?
It's kind of the norm. It's been decided by people over time, so we are supposed to stick to it.
That book, what did you use in your school? What did you study in your, I don't know, 8th standard, 9th standard? What is the grammar book you used? My God, nobody remembers what grammar book they used. Sorry? Wren and Martin. That's the one you used. You can't even repeat the name, huh? No, you say the name again. I'll tell you whether I used it or not.
I didn't hear you at first. That's why I was asking.
I'm just joking, man. But anyway, so we don't actually call back our grammar books, right? When we want to say a sentence, right? It's just basically from frequency. So if you immerse yourself long enough in people who speak bad English, you'll start speaking bad English as your first response. Then you'll have to start thinking about what is the right way to frame sentences, right? So we don't use grammar on a regular basis. It's more of the frequentist nature, right? So what happens is AI, basically all these large language models learn these frequencies or a huge corpus of text, right? Learn these frequencies across a huge corpus of text, and that allows them to actually generate meaningful utterances. So how do they work? It's something like this. So you can see. So the prompt here was recite the first law, right? And that went as the input and generated A, right? And A came back here, and then it went in as an input, it generated robot, and then robot came back here as an input, right? So now instead of the prompt being recite the first law, it becomes recite the first law, robot, and then what should be the next sentence. So it keeps going like this. This is called what's called as an auto-regressive way of prediction. So you predict one output at a time, and then whatever you predict goes back and becomes part of the input. Right? This is a basic structure. I mean, so this can become arbitrarily complex, right? but this flow is essentially the same, doesn't change. Okay, make sense? Then you can, of course, now give it a prompt, and then instead of doing that very slow animation I showed you, you can get it to generate a whole essay if you want, right? This is an old essay, right? So you probably, GPT-4 will probably do better for you. Apologize for the mess up in the slide. But the reason these LLMs are so popular now, or considered so powerful, is a lot of problems that we want to solve, right, can be thought of as next token prediction problems. Right? A lot of problems that we want to solve can be thought of as next token prediction. So here is a summarization query, right? So I give the prompt, which is essentially like the review somebody had written of the movie, right, or something, right? And then I want to rephrase that in a few words, ... And then it basically generates that text there for me, right? And likewise, I want to do sentimental analysis. This is a review of a movie, and on a scale of 1 to 5, and then it says 4, right? That tells you how strongly in favor or against the review was of the movie. Like, and likewise, some question answering. I'll give you the context and I'll ask you a question, and then you give me the answer based on the context that I asked you.
Sir, but how does it understand, like when I say stuff like give this certain essay in simple English, how does it know to search for it and then use different words?
It's just the volume of text on which it has been trained on. It's like mind boggling, right? It has probably been trained on like 100,000 examples of people doing paraphrasing, right, or people writing things in simpler English and things like that. So it has already been trained on these kinds of huge examples of what does the phrase write something in a simple English means, right? And then it tries to generate that. So it's like I said, the more context you give it, right, the better it becomes at generating the response, right? And the current models are really good. In fact, GPT-4, right? A, we don't know how large it is. B, we don't know what data it was trained on. Right? So, how many of you saw this video? This became very viral some time back. Somebody asked the CTO of the Chief Technology Officer of OpenAI, what was the data GPT-4 was trained on, right? And she couldn't answer. Not that she didn't want to answer, she actually didn't know. That she couldn't answer it with confidence, saying that yeah, this was the data that was used, this was not used, and so on and so forth. That's the volume of data that they were using. So when you start talking about that volumes of data, right, almost everything you have seen comes in. So one surefire way that you know that it is strongly dependent on the data it has seen, right? You ask it competitive exams questions, right? The performance of these models on exams that have already happened before the model was trained, it's very high, like 85% or something. The performance of these models on exams that happened after the model was trained is around 10 to 12%. So the significant bias that comes in from data that it has already seen, right? So quite often when you're asking questions like this, right, it's literally going back and looking at the former thing. And how many of you have noticed that even if you go back and ask ChatGPT the same question, it will not give you the same answer? Why?
Sure, because it keeps training on data and keep updating every moment.
That's part of the answer, right? So let's go back and look at our simple example that we had, right? Suppose this is the kind of data I was giving it to train, right? So some sentences would be I watched a match, some sentences would have been I watched a game, some sentence would have been I watched a movie. Now I give you a prompt I watched a and ask it to complete. What is the right completion for it? Not just the one that is the most frequent, right? If I keep saying the most frequent one, I would just be, so if say 5% of the people have said match, right, and 3% have said game and 2% have said movie or something like that, well, of course, if they ask the question in India, 20% said movie and 5% said match and so on and so forth. So next time somebody gives the prompt I watched a, 20% of the time it will say movie, right? 5% of the time it will say match. So even if the model hasn't been trained in the interim from the first time you ask the query to the second time, it will still give you a different answer because it is sampling from this distribution of responses that people have given in the past. Yeah. Sorry, you wanted to say the same thing. Okay.
Yes, sir.
Sorry.
Sir, while talking about the foundational models,
Yeah.
you were telling that they were unsupervised learning. They were characterized by that, right? Could you please elaborate on that? I'm not able to understand that.
See, that's what I was telling you, right? It's not really unsupervised. See, supervised learning is the following. I'll give you an input and I'll give you an output, right? Okay, this is a picture and the picture is a dog. I'll say picture and dog, picture and cat, picture and aeroplane. So that's what I give you. That is supervised learning because I'm telling you what you should say. But if I just give you a picture and say learn something about the picture, that is unsupervised learning because I'm not telling you what should be the output, right? But the foundation models do what is sometimes called as self-supervised learning because I give you the picture, I also give you the picture, same picture as the output, right? I'm saying, hey, you pass this picture I've given you, you pass it through your model and at the output I need to get back the same picture. Now, if I don't have any constraints on the model, this seems like a stupid task, right? I'll give you the input, you just give me back the picture. So what I'm saying is, it's not that. You have to take the picture, pass it through your function, and then the output should be the same picture. Now, that function can do all kinds of things, right? We saw the function can add noise and then remove the noise. Or the function can take the picture and make it into a, a 100-dimensional vector. A picture is like a 2D shape, right? And then each one has some value. Now I can take that 2D shape, make it into a 100-dimensional vector. So this could be like a 256 pixel cross 256 pixel image. I can make that into a 100-dimensional vector, and from that 100-dimensional vector I can recreate the image. So that function is, the form of the function is fixed. So the input is an image, output is an image, match it. So they call it self-supervised learning. So, but it's also unsupervised because I'm not giving you the specific time. Yeah.
So what do we mean by adding noise to a particular image?
I show you this goes there, right? Oh man, I had to go back so many times. I don't think my battery will last. That's the bit. This is added noise. This is some more noise, some more noise, some more noise. Yeah. So, is this clear when I say add noise? So basically, it is taking a function like this, right? Taking the pixel values here. So, let us say I take 90% of this pixel and 10% of this noise and produce this. Right? And how do I get here? Take 90% of this picture, 10% of noise and add it. Keep going until I get to 100% noise. So that's one way of doing the noise. I mean, that's just one way of doing it. There are many mathematical operators. So adding noise is not the mathematical addition. It's more English word. Yeah.
Sir, can you? We saw that in language models, the model can take some insights into the prompt that we give, and it is picking relevant phrases or words, and then it is framing it. Can you give some insight into how, the syntactical or grammatical accuracy is maintained in a language?
Good question. That's because a lot of the input that it was trained on is grammatically correct.
Sir, but isn't it trained on just lists of words and their meanings and things like that, or is it also given?
I told, is it also? It is not trained on a list of words and their meanings, right? Language models are trained on sequences of text, right? So if given a prompt, it learns how to generate the next word. So it would have been trained on I watched dash dash dash. It's not trained on just a single thing, right?
Okay, sir.
So it's trained on a sequence of words and it's learning to predict the sequence. So the training, suppose this had been the training version of it, right? The training version would have had, okay, if this is the input, right? And output should be A. Right, and if the A is here as input, the output should be robot, right? Not a robot. So if recite the first law A, then it will be trained to produce the output as robot, right? And like that. In fact, it does not happen in this sequence. I'll give the full input, I'll give the full output, but then while it is training, it trains on part of the input to produce part of the output. That is where all this, all the newer, all the attention mechanisms and transformers and all of these play a role, because I'll give the full input, I'll give the full output, right? The whole sequence. It's not trained on individual word meanings or anything. In fact, it doesn't know the word meanings. If you ask it what is the meaning of this word, it is probably producing the output from a dictionary somewhere that it has learned, where the meaning of the word is attached to it. Yeah, go on.
Sir, also this is probably an illogical question, but sometimes I've tried in Chat GPT, I give a very detailed question with a lot of context about what I want from a prompt, and it takes way too long to even, I'm talking about the speed of the generation, sir.
Yep.
So, is there any factor that determines the speed with which a response is?
Sure.
Because it has to retrieve from the.
So there are a bunch of factors, especially if you are using the free version of ChatGPT, right? Your priority is very low. Your priority is very low, right? So, so the amount of time, compute power that is allotted to you is very less. Therefore, the amount of time it takes to respond will be different. But apart from that, right, the length of the context window you give determines the speed of response also big time, because it really has to, run through the entire context window to set the internal variables correctly. So for that it takes a while, right? The longer the context windows you give, the longer the generation is going to be. So literally it has to read through the text bit by bit, and so for every piece of text you pass through the system, it's going to change the internal setting of the system. So finally, when you come to the last bit where you are asking the question, right? If you just ask the question, it will give you a very different answer. The whole idea of this context setting is to put the internal state of the system in the right value, so that when you ask the prompt, it will give you the right answer.
So,
It literally reads the text you gave bit by bit. Yeah, go on.
So if we ignore the time complexity, the accuracy of the answer will be more provided we give more.
Yeah. Mostly. Okay. Yeah.
So,
I have one eye on the time. That's all. Yeah.
the example where you gave about the self-supervised testing model, you gave the example where a function is applied on the example, the input which is given, and what uses of that function which is employed over that input.
So that is the function that you chose, right, to model your behavior. Remember, so you choose whether you want to do a straight line or a slanting line or a curved line and all that, right? In the beginning when we did this function. So something similar, right? The same role the function plays. This is the form that you want for the generation.
Okay, then why do we call it the same output when
The same input is the same output, right?
when we do want some changes in the input?
Meaning? I don't quite get it. So you are asking, why are these self-supervised model producing the exact same output? Because what I really wanted to do is produce something novel.
Yeah.
Okay, good. So what these models are learning, right, is essentially the distribution of the input data. Right, so I'm giving you, let's say I give you 1,000 pictures of dogs, right, and then I'm learning to produce dogs outside, right. Now what I do, I'm not going to give you a picture of a dog when you're operating, right. I'm just going to say, hey, give me a picture of a dog, right. So I'm literally starting from whatever is the 100-dimensional vector I learned, and from there I'm going to generate the picture of a dog. I'm not going to start from the picture of a dog and generate a picture of a dog. Right, now when this process is happening, right, this will introduce your novelty that you want, because it is not quite retrieving a point from the training data. It is trying to reconstruct something from the data that you have seen. That reconstruction process needs to have some structure, and that is a function that you are learning.
So the thing which the function obtains here is used somewhere else, so that we get an.
Sir, in diffusion models, what does SDE stand for?
Ignore all the math I put in there. No, it's like it's a long paper. I mean, so we should have just cut the picture alone. But my student cut the one line above that and one line below. So ignore the math. Sorry. Okay, fine. So very quickly, this has become significant productivity boost, right? I mean, people are writing programs like 100 times faster than they used to write last year, right? Of course, people are copying 1,000 times faster than they used to copy last year. That's a challenge, right? And but a lot of things, right? So the way people write stories, show fakes and stuff like that, everything has changed significantly, right? And yeah, look at this. Isn't this amazing? They were able to write and illustrate a book in 10 days, and he actually got it published. Right, so this is amazing stuff, right? And ChatGPT now people are. So when you guys go out and find a job, right, you better know how to use your Copilot for doing whatever field that you're going to go into. Doesn't matter what you're going to do. So you don't have to be a programmer to be using Copilot, right? If you're going to become a journalist, you'll have a Copilot for that. If you're going to become a lawyer, you'll have a Copilot for lawyers, right? That will do referencing of cases and things like that, and helps you frame your argument in the right way, etc., etc. So all of these things, these models are going to do, right? So the way we will work is changing. I mean, as a teacher, right, you're going to have a Copilot that helps you, put material together, and of course helps you find when your students are using their own Copilot when they shouldn't be. Right, so all of these, right? So things are going to be very, very different. So I have another 80 plus slides, and we have 4 minutes. So I don't think I'll be able to get through all my material. So please feel free to ask questions. This will be my last slide.
So like basically in diffusion models, you not ask about the math, but then like we are differentiating like based on various factors first, and then we are integrating it back again. So it basically works like in chemistry.
So the way it works is inspired by some kind of phenomena in physics, right? So the whole diffusion model is literally about how a disturbance would diffuse in a system, right? So either heat diffusion and things like that. So the way they talk about it is by the math behind it looks at it as a differential equation, gradually, mixing the. Let me look at it. In fact, they look at it. If you want the actual math, they look at it as a continuous time Markov chain. So if that made sense to you. So Markov chains are essentially used for modeling dynamical systems, right? So you start in some state, right? You start in some state, and then over time the system just changes state using some fixed laws of dynamics, right? And that could come from some partial differential equation or whatever. So the diffusion models essentially model that whole noisification and denoisification process as a continuous time Markov chain. So, and then they solve a whole bunch of differential equations to get there, and they do that by making certain assumptions about it and coming up with neural network architectures that actually solve the equations for them. And they don't actually sit down and use a solver; they actually use a neural network to do that.
So no one can accurately predict the output to a question we ask ChatGPT. So do we relate it to a black box problem, or do we just say that as a result of the amount of data that is fed? See,
the more accurate you become in your prompting, right? The more elaborate you become in your prompting, the more deterministic you can be about the output.
No, because every time we enter the same question, we get different answers. So even the programmer wouldn't be able to accurately tell from which source.
You are not listening to me. The longer your question is, right, the more accurate the answer will be, and the more deterministic the answer will be. The reason is the following: the non-determinism in the output of ChatGPT, right, basically giving you a different answer every time, is because there are potentially many different completions for the prompt that you have given based on the data it has seen.
More accurate. The question is not accurate.
Yeah, the question has, admits many different answers. Just like I asked you, right? I watched right? Admits many different answers, including a monkey, right? So, but if I start making it lot more particular, right? In I don't know, in Chennai Chepauk Stadium on some date, I watched CSK play. Right. Then it probably will tell me Gujarat Titans or something like that, which will tell me the same answer every time. Right. So the more accurate I become in my prompting, the more deterministic answers will be. Okay. Fine. So yeah, go on.
Not a doubt, sir. Could you please switch to the slide of learning and adaptation first aid? A flowchart I would like to comment.
Put that on so that they can record you. Okay. What was the question again?
Sir, actually not a doubt. Could you please switch to that slide?
I have a question. Are the slides, will they be made available to the students? Are you getting the slides of the other lectures? No? One lecture. I am happy to give my slides to you guys. You still want to copy the flowchart? Oh man. Even if I give you the slides, you just don't trust me.
No, sir, not like that. Sorry.
I think the battery will die before I get to that slide. Tell me when. This one. Okay, sure. Okay. So any other questions, guys? So I had a whole bunch of slides about how these models fail, what are the reasons for them to fail, and things like that. But wait for another day. Sorry? Louder. The slide deck, full slide deck. Okay, happy to. Yeah. And but how do I'll send it to him. He can share it with you. Cool. Okay, folks. Thanks.
I want to thank Sir so much for providing the lecture on the most important and relevant thing in today's world, being AI. We really understood the effects, past, components, and the operations of the AI with its hype in today's world. We are very fortunate to have got this wonderful opportunity to learn from you and want to thank you for coming out of your busy schedule and teaching us. I request everyone to put down their hands for such a passionate and inspiring professor. We are awaited for another lecture from you, sir. Thank you.